sort of testifies the point that maybe CAT 2023 was really difficult. So with this, let us move ahead. This is your standard arithmetic progression question. All right, they have given you that there are two APs, A1, A2, A3, B1, B2, B3, so on, such that the common differences of both the series are prime numbers. Now, what they have given me is A5 is equal to Bn, which means A1 plus 4D1 is equal to A2 plus 8D2. Correct? The second result that they have given me is A19 is equal to B19, which means A1 plus 18D1 is equal to A2 plus 18D2. Furthermore, they have given me B2 is equal to 0, which means A2 plus D2 is equal to 0. So they have given me, technically they have given me four variables, A1, D1, A2, D2, and they have only given me three equations. What is the extra thing that they have given to me? That D1, D2 are going to be prime numbers. So instead of giving me four equations, they have given me three equations plus one constraint. And using these, I have to arrive at the values of A1s and D1s. So what is it that you guys are thinking? The immediate thing to do is I can go ahead and find the ratio of A2 and D2, which is -1, which means A1 plus 4D1 is equal to minus, I'll put everything in terms of D2 because it's prime. So A2 is minus D2, right? So this is 7D2, and A1 plus 18D1 is equal to 17D2. So far, I think we can keep it like this. Fair enough. Uh, this will give me the ratios of A1 and D1. All right. Now, in this particular step, it is getting tricky because I have not really yet used, if I divide these two, I've not yet really used the fact that D1 and D2 are prime numbers. So we can instead focus on this aspect that, boss, I can actually remove A1 and A2 and I can actually find a relationship between D1 and D2. If you subtract these two equations, you will get 14D1 is equal to 10D2, or 7D1 is equal to 5D2. Now D1 and D2 are prime numbers, which means what? D1 will have to be 5 and D2 will have to be 7. The fact that they gave us the fourth result as a constraint and not as an equation is something, first of all, most people would have not even used. And once you have this, you can actually find the values. You have D1 is equal to 5, you have D2 is equal to 7. After this, you can get A2 is equal to -7, and all that remains to be found is A1. Right? And you can put it in either of the equation, find A1, and then you have to find A1 plus 10 D1. Question number 2. AN is this, BN is this. These are two sequences for n less than equal to 100. Then the sum of all the terms common to both the sequences are. So the first step is going to be what? I need to find the common terms. Correct? So first term, I have to find the first common term. This is 46 plus 8n, and this is 98 plus 4n. I want to find a term which is common to both of these. Now, obviously, the n value of that term is not going to be same, right? So, basically, I'm not saying that fifth term of the first sequence will be equal to the fifth term of the second sequence. So, first you will have to do hit and trial here. You will have to fix these, and now consider this, that this is 46 and this is 98. So you do need a substantial value here to even reach close to 98. So I am thinking 8 into 5 is going to be 40. So n is equal to 5 will give you 86. After that you will get 94, and then you will get 102, which is going to be common with this. Correct? 102 will also be present in this term. So n is equal to 7 for the first sequence and n is equal to 2 for the second sequence. 102 is your first common term, and what is your common difference going to be? The LCM of 8 and 4, which is 8. So an AP which starts with 102 has a common difference of 8, and I will now find the sum of all the terms which are common to these. The problem here is what? What is something I still have to figure out? the fact that n is less than equal to 100. So what is the last term that I can take? Which is the largest term in this sequence? 100, that is 846. Correct. And which is the largest term in this sequence? 498. Which means you cannot cross 498. So your first term is going to be 102, your common difference is 8, and you will have to find the sum until you stay below 498. So first of all, you can check, is 498 even part of this AP? So 498 minus 102 is going to give you 396. And now tell me, is 396 divisible by 8? 32, 76? No, it is not divisible. So 494 would be your last term. Correct? So this is your first term, this is your last term. You can now, still your work is not done. You will still have to find the number of terms that are there. Correct? Which you can find as 494 minus 102, that is 392. And if you divide this by 8, which is the common difference, you will get what? 49. So how many terms do you have in this AP? 50 terms. Because it is taking you 49 Ds to get from 102 to 494. So your answer will be 50 by 2, n by 2 into 2a, or you can actually then do 50 by 2 into first term plus last term. Correct? So 102 plus 494 by 2 you can do. That is going to be again, so obviously answer will have 0 at the unit digit. So this will be 494 plus 102, that is 596. So yeah, this would be easier instead of going with 2a plus n minus 1d. So mth and nth term of a geometric progression are 3 by 4 and 12 respectively, where m is less than n. Now I am noticing a constraint that they have directly given to me, and now we know how equation and constraints both are important in figuring out the exact values. So let me write this result. Uh, a to the power a into r to the power m minus 1 is equal to 3 by 4, and a to the a into r to the power n minus 1 is equal to 12. Now what they have asked me for is r plus n minus m. I need to get n minus m constructed in this, and the best way to do that is what? Divide this with this. There's no point in taking logs here. You don't even know of what you will take the log. So if you divide this, you will get r times n minus m is equal to 12 divided by 3 by 4, or 4 square, that is 16. R to the power n minus m turns out to be 16. Now let us look at the facts that they have given to me. M is less than n, which means this power is going to be positive. And obviously, because these are term numbers, these are going to be natural numbers. So how can I write 16? I can write 16, and they've already told us that the common ratio is also an integer. So we have to find the smallest value of this. So let's write. First, let's take r as positive. So this can be 16 to the power 1, this can be 4 to the power 2, and this can be 2 to the power 4. No other situation. If you take r as negative, this counterpart will not be allowed, because you will take minus 16 here, but you will have to raise it to an even power to convert it to positive. So minus 16 counterpart is not allowed. Minus 4 counterpart is allowed. You can have minus 4 to the power 2, that is allowed. You can also have minus 2 to the power 4. So the minimum value of r plus n minus m, which is basically base plus power, is actually going to come from this situation, which is minus 4 plus 2, which is minus 2. Consider the arithmetic progression 3, 7, 11, and let an denote the sum of first n terms of this progression. So an is going to be n by 2 times 6 plus n minus 1 into 2a plus n minus 1 into d. What is d here? 4. This is the value of an, which is at the end going to be 4n plus 2 divided by 2. So n into 2n plus 1. Correct? This is the value of an, and an is given to you as what? 2n square plus n. And now they are asking you to do what? Add ans from 1 to 25 and divide it by 25, which will turn out to be 2 into 1 square plus 2 square plus 3 square till 25 square, plus 1 plus 2 plus 3 till 25, this whole sum divided by 25. So if you don't know what this expression's value is, you could not have done this question. So now what you will do is you will just put the values here, 2 into uh, n into n plus 1, that is 26, into 2n plus 1, that is 51, divided by 6 plus n into n plus 1, that is 25, into 26 by 2, and this entire thing divided by 25. 25 you will cancel, then you will simplify this further and finally arrive at your answer. Slot 2, sum of infinite series. Now first of all, finding the first few terms, for example, is not going to be something that I'm going to do here. It is going to get messy. All right, and these are infinite series, so I don't really feel like finding the first few terms. Okay, now first thing I will observe is that this 1 by 5 is getting, carried forward as a GP. 1 by 5, 1 by 5 square, 1 by 5 cube, and so on. However, the problem is that this part is not carrying forward as a GP. This is 1 by 5 minus 1 by 7, and then this is 1 by 5 square minus 1 by 7 square. This is not 1 by 5 minus 1 by 7 whole square. If that was the case, I would have had my infinite GP directly written in front of me. So this is on the face of it not an infinite GP. However, I do get a sense that GP is getting used. What is the first thing? What is the first instinct that clicks me? Do you see how individually the terms inside are in infinite GP? They are. So why don't I separate them? Why don't I write this as, and this was the part that was, required in this question. Let me write all the five terms together. 1 by 5 square plus 1 by 5 to the power 4 plus 1 by 5 to the power 6 plus 1 by 5 to the power 8. Is this an infinite GP? Yes, it is. What about 5 and 7? I will get 1 by 35. This will all be with a minus sign. Plus 1 by 5 square into 1 by 7 square. This is 1 by 35 square plus 1 by 35, you know, uh, 35 cube, and so on. So you have first one, an infinite GP with the first term of 1 by 25 divided by 1 minus common ratio. The common ratio is also 1 by 25. This is going to be this sum. What about the second one? This is going to be 1 by 35 divided by 1 minus 1 by 35. So your answer actually for this question is going to be 1 by 24 minus 1 by 34. This is going to be your answer. All right, and I think this will turn out to be 5 by 408. An infinite geometric progression, A1, A2, A3. They have given it to me already that this is an infinite geometric progression. Has the property that An is equal to 3 times sum of the next few, next upcoming terms for every n greater than equal to 1. Furthermore, they have actually given me the sum of all the terms in this GP. Then A5, they are asking me for A5. To find A5, what do I need? I need A and I need R. These are the two things that I need. So which means I need two equations. Where will I get my two equations? First of all, A2 plus A3 and so on is going to be equal to what? A1 is going to be 3 times A2 plus A3 and so on, which means A2 plus A3 so on is going to be A1 by 3, which means A1 plus A1 by 3 is equal to 32, which gives me 4A1 by 3 is equal to 32, or A1 is equal to 8 into 3, that is 24. Correct? Now I need to find my R. How will I find my R? Using the sum formula. A1 divided by 1 minus R is equal to 32. So 1 minus R is equal to 3 by 4, or R is equal to 1 by 4. So now from this I can find the value of A5, which is going to be A1, that is 24, into R to the power 4. That is going to be 1 by 4 to the power 4. So this is going to be actually 2 to the power 8, and this is 2 cube into 3. Yes, so this will cancel out. This will become 3 by 2 to the power 5. That is 3 by 32. Option C. This is what I meant by fractional sum. A1 is equal to this, A2 is equal to this, A3 is equal to this. Are the factors of the denominator having a common difference? Yes, they are. Which means when I add these, I will do 3 and 1 by 3. 3 by 2 into 5 plus 3 by 5 into 8 plus 3 by 8 into 11 and so on. This then I can write as 1 by 2 minus 1 by 5 plus 1 by 5 minus 1 by 8 and so on. Now, this is my sum. What is the last term that I'm going to get? So, if you see 2, 5, 8, they are in APs, right? So, your A100 will be actually 2 plus 99 into 3. That will be 299. So, A100 would actually be 1 by 299 into 302. So, this you can write as 1 by 299 minus 1 by 302. This 299 will get cancelled. Now one of the key ways to ensure that you don't cancel out the wrong term, the positive term is remaining here, the first term is remaining here, which means that the last term will be remaining on the end. So your answer will be 1 by 3 into 1 by 2 minus 1 by 302, which is going to be 151 minus 1, that is 150. 150 by 3, that is 50 divided by 302, or 25 by 151. Or you should actually write this step by step also, and you will realize what has to be cancelled. Clear on this? This is second example of your fractional sum. A1, A2s are in AP. You have something which is obviously something I'm not going to deal with at all. Correct. I will convert this. How do I convert this? This becomes root A2 minus root A1 upon A2 minus A1. If I rationalize this, A2 minus A1 is the common difference, plus root A3 minus root A2 upon common difference. So what I see here is all these are getting cancelled, and I'll be left with root of an plus 1 minus root of a1 upon d. I don't have the options here, but after this you could have converted this again into one of the options. So the key here was to rationalize the denominator, which gives you a new denominator which is equal for all. This is your Sn. Now the thing that I have observed is term, there are terms that are in GP. All right. And something is getting added to each term. So what I'll do is I will multiply Sn with this 1 by 4, and I'll get 1 by 4 plus 1 by 3 into 1 by 4 square plus 1 plus 1 by 3 plus 1 by 9 into 1 by 4 cube and so on. Now once I subtract this, I'll get 3 Sn by 4 is equal to Sn minus Sn by 4 is equal to 1 minus 1 by 1. Then I'll get minus this thing minus 1 by 4, which is 1 by 3 into 1 by 4. Then I'll get this thing minus this thing. This will become plus 1 by 3 square into 4 square. Can you spot the sequence? Yes, this is an infinite GP. 1, 12. So common ratio is 1 by 12. So your answer will be that 3 Sn by 4 is equal to first term, which is 1 here, divided by 1 minus 1 by 12. So you will get Sn is equal to, I think, 16 by 11. Now, T1 is equal to 1, T2 is equal to minus 1, and Tn is expressed in terms of Tn only. Correct? Instead of giving you an explicit formula for Tn, what are you given? You are given Tn in terms of another term in that sequence, which means what? Maybe I should build this sequence up from the ground and see if there is going to be any pattern. Correct? All right. So the only way to do this is to actually identify what that pattern is going to be. So T1 is equal to 1 and T2 is equal to minus 1. So T3 is going to be 3 minus 3, that is 0. Okay. T4 is going to be 4 minus 3, that is 1, divided by 4 minus 1, that is 3, into T2, which is minus 1. So T4 is actually minus 1 by 3. Now T5 will again be equal to 0, because T5 will be something into T3. So I have already gotten the sense that odd terms are going to be all 0, which is why they have not included that even in the sum. Correct? Because then you would have gotten 1 by 0. So I'm now not going to focus upon the odd terms. They have not asked me for it. I will not focus upon it. T6 is going to be 6 minus 3, that is 3 divided by 5 into minus 1 by 3. So T6 is minus 1 by 5. Now I only need to, I sort of know what the pattern is. Maybe just one more term if I'm confused. T8 is going to be 8 minus 3, that is 5 by 7 into minus 1 by 5. So this is minus 1 by 7. So this tells me that 1 by T2 is minus 1. Okay, 1 by T4 is minus 3. 1 by T5 is minus, sorry, 1 by T6 is minus 5, and so on. Which means what do I have? Minus of sum of first n odd numbers. And till what odd number will I go? So this is T2024, right? So this would have been 2023. The last number would have been 2023, which means the number of terms are how many? 2023 plus 1 by 2, that is 1012. 1 plus 3, how many terms are here? 1 plus 3 by 2. 1 plus 3 plus 5. How many terms are here? 1 plus 5 by 2. So till this sum till 2023, how many terms will be here? 2023 plus 1 by 2. So this is actually sum of first 1012 odd numbers. So the answer will be minus into 1012 whole square, which is going to be this. Clear? Yes? All right. Let's look at one more example. A lab experiment measures the number of organisms at 8 a.m. every day, starting with 2 on first day. The number on any day is equal to 3 more than twice the number on the previous day. All right, which means that Tn, is equal to 3 plus 2 times Tn minus 1. Correct? So again, feels like because term is given in terms of term, I must find some pattern here. So T1 is equal to 2, which means T2 is equal to 3 plus 2 into 2. So this is 2 square. T3 is going to be 2 times 2 square plus 3, which is going to be 2 cube plus 3 times 2 plus 1. T4 is going to be 2 times 2 cube plus 3 times 2 plus 1 plus 3, which is going to be 2 to the power 4 plus 3 times 2 square plus 2 plus 1. That is 2 square plus 2 plus 1. Now I can find what my Tn is, correct? I already have the pattern. Tn is going to be 2 to the power n plus 3 times 2 square plus 2 plus 1 is equal to what? 7, which is 2 to the power 3 minus 1. So this is 2 to the power n minus 1 minus 1. Correct? So this is the value of your Tn. And now you have to check if the number of organisms of n they exceeds 1 million. So you want to find the value of n after which this is greater than 10 to the power 6. Even after this is honestly, calculative. Not a lot of easy ways out of this. You can probably convert this into 2 to the power n is actually 2 into 2 to the power n minus 1 plus 3 into 2 to the power n minus 1 minus 3 is greater than 10 to the power 6, or 5 into 2 to the power n minus 1 minus 3 is greater than 10 to the power 6. So after this, you can probably go for hit and trial. 2 key powers, again, you will have advantage. You already know 2 to the power 10 is 1024. You can use that. So you can perfect square this. You already know 1024 whole square will be something greater than 10 to the power 6. Because 1000 square will be 10 to the power 6. So 2 to the power 20 is not going to be your answer. So you can then make your work, way backwards from there. 1024 square will actually be very close to 1000 square. So you can make your way backward from 20, and I think the first value itself will give you your answer. All right, moving on. On day 1, there are 100 particles in a laboratory experiment. On day n, where n is greater than or equal to 2, one out of every n particle produces another particle. So again, Chetali, do you feel like we should write the terms, correct? So T1 is equal to 100. T2 is going to be uh, all the 100 from the previous one plus, so because this is day number 2, every 2 will produce 1. So this will be 100 by 2, that is 150. T3 will be this 150 plus, now every 3 will produce 1 extra. So you will divide 150 into groups of 3 and this becomes 200. Do we have a pattern already? 100, 150, 200. This is somehow an AP. So the AP is 100 plus n minus 1 into 50. Now this you want to be equal to 1000. So you will get this is equal to 900, or n minus 1 is equal to 18, or n is equal to 19. So again, write the first few terms and be on the lookout for what the pattern can be. And this would be another example of this. Now the idea that I have to find first few terms, that is clear. Do you also get the sense that there should be some sort of repetition happening? Do you see this screams block pattern? Because look at the options and look at the initial values, they are so close. Furthermore, x is actually 1 plus something by x, so there is no degree here. There is no degree here to cause some sort of exponential growth or something which links towards repetition. So let me write 1 is the first term, second term is 2, the third term will be 1 plus previous term divided by the second previous term. So this will be 1 plus 2 by 1, that is 3. The next term will be 1 plus 3 divided by 2, that is 2. The next term will be 1 plus 2 divided by 3, which is 1. Now I started with 1 and I already have 1. Let me find the next term. The next term will be 1 plus 1 divided by 2, that is 1. Now the next term will be 1 plus 1 divided by 1, which is 2. So 1, 2, 3, 2, 1, 1, 2, 3, 2, 1 is the pattern that is going to get repeated. However, it is starting from term 0. So 0th term will have the same as 1, 2, 3, 4, 5, then 10th and so on. So the 202th term will actually be 1, which means 2021th term will be 2. Yes. So a lot of people actually make this mistake that this is the fifth term and they put 1 as an answer. I think a lot of people made this mistake, but the issue is that the sequence is starting from x0. So the endings are 5 into something minus 1. Right? So just be clear on how to propagate once you make your groups. Moving on. Uh, this is the sequence that is given to you for all natural numbers n. Then the sum x49 plus x50. Now, in this situation, probably finding x1, x2 does not make any intuitive sense because they are already included here and there are n numbers included. So, what this is instead screaming is maybe I should put values of n. Let us define this as x1 minus x2 till, let me find this till 48, right? And the reason why I'm finding this till 48 is that because 49 and 50 is being asked, right? So let me put n is equal to 48. So I'll get minus 1 to the power 49. The last term will be minus 1 into x 48. This is 48 into 50. Now the next I will put as 49. I'll get x1 minus x2 minus x48 plus x49 is equal to 49 into 51. Now if I subtract these two, I will get x49. Correct? Now let me write the next one. X1 minus x2 so on minus x48 plus x49 minus x50 is equal to 50 into 52. So this minus this will give me plus x50. So my approach is clear. 2 into 49 into 51 minus 48 into 50 minus 50 into 52. This is what I have done. Why this 2 is here? Because I am doing this minus this plus this minus this. So this is coming with positive sign 2 times. All right. Once I do this, this becomes what? 50 into 100, so 5000 minus 2 into this is 50 minus 1 into 50 plus 1. So this is 50 square minus 1. 50 square is 2500. 2500 into 2 would be 5000. So this will cancel with this. You will be left with minus 2. So your answer for this question is going to be minus 2. All right. Consider a sequence. This can I? Okay, I'll just do it, yeah. Now we are already in flow. So you have xn plus 1 is equal to xn plus n minus 1. Now, because it is given like this, one term is equal to, something in the same term sequence plus some result. So I will feel the need to put the values. And what are the values I will put? I will put n is equal to 1. So x2 is equal to x1. x3 is equal to x2 plus 1. x4 is equal to x3 plus 2, so on until I will go till x100 is equal to x99 plus 98. Now when I add all of these equations, x2 till x99 will cancel with x2 till x99. This is cancelled, this is cancelled. I will be left with x100 is equal to x1 plus 1 plus 2 till 98. A sum that I know as 98 into 99 by 2, and into n plus 1 by 2. X1 is minus 1. X100 is going to be equal to this. This you can calculate as 4850. So when you have direct correspondence like this, na plus plus sign, you should write these and add the equations. The terms will cancel out. Now, this is the difference of summation that I was talking about. T1, T2 are real numbers. This is actually Sn given to you if you look at it. 2n square plus 9n plus 13. Now, they are saying that Tk is equal to 103, which means Sk minus Sk minus 1, which is going to be 2 times k square minus k minus 1 square plus 9 times k minus k minus 1 plus 13 minus 13, which is going to be 0. This is equal to 103. Now this is going to be equal to 1. So this is 9. And this is 2 times k plus k minus 1, that is 2 into 2k minus 1 into k minus 1, which is 1. So 2 into 2k minus 1 plus 9 is equal to 103. Yeah. Okay. So you can't really, calculate each of these terms. One of the few, methods people think is you can write this as 9 square minus 2 square. Then this you can write as 13 square minus 2 square. And which is a novel effort. You can do that. However, how will you find 9 square plus 13 square plus 17 square? There is a method for that as well, because you can express 9 in terms of the AP terms, but might as well just do with the AP. So the general term of the 7, 11, 15 sequence and general term of 11, 15, 19 sequence, when you multiply these two, you will get your answer. So the Tn will be 7 plus n minus 1 into 4, right? So that is going to be 4n minus 4. So this is 4n plus 3, correct? Into this will be 11 plus 4n minus 4 again. So this will be 4n plus 7. So 4n plus 3 into 4n plus 7. So now you will write this as 16n square plus 7 into 10, 40n plus 21. This is Tn. So when you add this, you will find the number of terms. Then you will put this as 16 into sum of first n squares plus 40 into sum of first n's plus 21 into n. Don't forget this constant. Whatever this turns out to be will be your answer.